Let's do it again. DJ's tuning in. All right. So today we are going to talk more about Keynes' main theory with a focus on spending. And last time we left off talking about the aggregate expenditures. And so I want to start off today thinking about the spending that goes on, kind of similar to our banking concept of how we track money through. Keynes' idea was that, well, money kind of gets spent over and over, right? So if you go buy something at the store and that revenue gets paid out to the owner of the store, and then they go run to another store and buy it. So there's kind of this effect of consumption being multiplied. So that's what we're going to start off today on. So the spending multiplier. Spending multiplier. Okay, so Keynes' idea again was, in general, use government policy like G, government spending on weapons of mass destruction. Use government policy like G to stabilize the economy. Not a bad thought. And so, for example, suppose the government increases government spending. Suppose the government increases government spending by 50 billion bucks. All right, so they kind of inject 50 billion. Maybe it's some weapons of mass destruction. They run down to Guns R Us and pump up some military spending. So when they do that, it ends up going into Guns R Us cash register. Right? That's a big check. But so revenues look pretty good for Guns R Us. So to track this through, there's an increase in government spending of 50. Which is an increase in income of 50. So Guns R Us, Guns R Us gets $50 billion check. Pretty sweet. So the cash register rings up 50, right? So one government spending turns into somebody else's income. Whoever the owners are of Guns R Us, they now have income to the tune of the 50 billion. All right, so what do they do with it? We talked about the marginal propensity to consume last time. What was that? Just make it all the way around, right? Sign-in sheet. marginal propensity to consume. What do you got in your notes about that? Marginal propensity to consume. What was that? It was related to the MPS too, which was the marginal propensity to save. But what was the definition of the marginal propensity to consume, Jake? Good. The fraction of your income that goes towards consumption. Well, the Guns R Us owners now have income of 50, and so they're going to go spend at least some fraction of that, the marginal propensity to consume. So if marginal propensity to consume is 0.2, I'm sorry, 0.8. If the marginal propensity to consume is 0.8, what is the marginal propensity to save? 0.2, because they had to add up to 1, right? So we did that last time. We kind of showed that equation. If I'm not consuming, I'm saving is how we've got it set up. So if the marginal propensity to consume is 80% or 0.8, then how much of this income gets spent? 80%, which is what? Now I want some numbers. I think we can do this one in our head. 40, good. So I always give, 10% of 50 is 5. 20% then would be 10, right? So 80% of that, you'd be spending 10 of it. So this income turns into somebody else's consumption. Consumption now goes up to 40 million. So that consumption now, well, what did they do? Well, they ran to Applebee's. They ran to Applebee's, and that ended up getting deposited into Applebee's checking account, and that meant that income is now up again by 40 million. Now the owners of Applebee's, what do they do with it? They consume 80% of it. So 80% comes back to consumption. 80% of 40, let me do this math on this one, I probably should have did it up here. 0.8 times 40 equals 32, right? And so we've got consumption going up. That, of course, gets into somebody else's paycheck, and so that goes up by 32. And so on, and so on, so on. So by starting off with a little bump of weaponry by the government, we end up creating additional spending as well, right? So if we go back to our expenditure approach, our cigarettes, the government's bump up here, an increase of 50, now led to additional bumps in consumption here of 40 plus 32 plus dot, 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 dot. So the government adding to the system created GDP or income increases that were greater than the initial bump. That's pretty nice. Pretty interesting result. So we get this multiplying effect, the spending multiplier. And the way to calculate the total effect would be to add up all of these numbers. We can run an Excel spreadsheet until we drive this number to its infinitely small and add them all up. Well, similar to our deposit multiplier, who remembers what that is? The deposit multiplier from 3 chapters ago or 4 chapters ago. what was it? The deposit multiplier. It was the change in the money supply. This was on your test. The change in the money supply equals the deposit multiplier times the change in excess reserves. What was that shortcut method that we had there? That deposit multiplier was equal to what variable was it related to? Remember, I had the whole money that was in my checking account, and I cashed a check. This is thinking back to the test. Who found that? Yes, it's related to the required reserve ratio, RRR, and what was the deposit multiplier? Basically, the calculation of the deposit multiplier. Yep, 1 over the triple R. That was it. Right? So 1 over the triple R was the deposit multiplier. And so we've got kind of a same thing going on here with the spending multiplier, but ends up being 1 over 1 minus the marginal propensity to consume. So the change in government spending equals the change in income. So government bumps us up 50 million. It leads to a total change after working through the multiplier of 1 over 1 minus the marginal propensity to consume. So for this problem, what is it? 1 over 1 minus 0.8, which equals 1 over 0.2. And so what's the multiplier? 1 over 0.2. Who's got their thinking cap on? Let's see. 1 over 0.2. 1 over 2/10. Something in the fraction in the denominator. Flip it over. Multiply it times the numerator. What's the, how much? 5, right? So 1 times 10 over 2 equals 5. So the multiplier in this case is 5. So I get the change in government spending. The government kicked in 50 billion, I guess. And so I get 5 times 50 gave me a $250 billion change in income. All right, some questions on that. So this thing's called the simple spending multiplier. The real one is a little bit more complex. And more generally, it's called the autonomous spending multiplier. So let's throw on a couple notes here. So important notes. This is more generally called the autonomous spending multiplier. What was the word autonomous from last time? Loading you guys up here with big quizzes today. Autonomous. What you got on that? Independent of income, right? So we had the autonomous part of consumption, and then we later added on the autonomous government spending and autonomous investment. And so it was independent of income. We're just kind of letting it drop out of a spaceship into our world, and it's not based on income. Then it becomes somebody's income, and then we kind of run through this process, right? So we can use this for other types of spending too. So more generally called the autonomous spending multiplier, this can be used for other autonomous spending. like investment, which is what we did last time. Investment and little a was our autonomous consumption from our consumption function. One over 1 minus the marginal propensity to consume could also be rewritten as 1 over, this is what we did last time, kind of clean it up. Melanie, you look like you're somewhat chomping at the bit there.
I'm good.
You're good. So 1 minus the MPC was also equal to the MPS, the marginal propensity state. So this is kind of a clever little homework test problem that you might have to go either way to come up with the multiplier. So notice 1 over the MPS gives you the same result. The marginal propensity to save in this case was 0.2, and ultimately that's what we ended up doing, 1 over 0.2. So you can kind of think about it either way. So that's it, and this is called the simple spending multiplier. Simple multiplier. Why, you ask? Simple multiplier because we're assuming no taxes and no imports. Because there's no taxes and no imports. No taxes and no imports, which isn't a very real world, but it ends up being the multiplier under that set of cases. So there's a more complicated one that we're going to do here in a little bit too. All right, so questions on that so far? All right, so let's take a peek at this graphically. All right, so it's still in. So this is where we left off graphically last time. We're measuring real GDP or income or production. We kind of used those words interchangeably last time. And then we've got spending, aggregate expenditure on the vertical axis. So you can kind of think about this as being spending and this as income or production, depending on our interpretation. And we draw our 45-degree line. See what did I do today? Ooh, that was better. Still a little fat down here, maybe. Our 45-degree reference line was just there to show all possible equilibrium points. So in the long run, we'd expect there to be income equal to spending. Those two kind of have to be in harmony with each other. So that line is not really a function at all. It's just a statement that says, hey, if the economy is in equilibrium, these two things will be equal to each other. And our aggregate expenditure line has some slope to it. And then we said, well, this is where we'd expect to be in the long run, where the two lines cross. What was the adjustment that took place in the economy if we weren't in equilibrium? It's kind of a new concept that's kind of interesting to think about. What was the adjustment? So if we weren't here, we had spending above production or production above spending. It created an output gap. And so what was the thing that was acting as a signal for producers to either produce more or less? What were they keeping an eye on? Their inventory, right? So their inventory of goods. So we have inventories that are going to be watched on whether they're going down or up. In your aggregate C plus I plus G plus X, the cigarettes, inventory is actually unsold final goods and services are in the I part of that. So we have tractors, buildings, machines, brand new construction in the C plus I, the I part, but we also have unsold inventory. So that is one of the factors, and that's where it shows up in the income accounts. All right, so if we have this increase in government spending of 50 billion, which I erased already, I guess it was here, what happens to this line? If it goes up by 50 billion, what happens to the aggregate expenditure line? We did it last time. Look back in your notes. We didn't do this exact problem, and we built up to it. It shifts to the left like this. Now, is it really, now this one, it's kind of a technicality. First of all, you're right. Should we think of it as shifting left or up? Up. Now, on this particular case, because the autonomous part of the government spending was the endpoint here, and so it's literally being shifted up by the $50 billion. So we don't have to be perfect, but let's just go and do a parallel shift up to AE2. And from a notation standpoint, you can think of AE1 and AE2 as at G1 levels. Let's call it G1, and this is at G2. $50 billion higher. So we went up 50 billion. And now we can start to tie down our endpoints here. So here was our original level of GDP. Here's our new level. And your graphs may not look as, I tried to do mine a little bit different here. What's true about this distance, the increase in G, it's a parallel shift. So the vertical distance here is the change of G. So the increase of G equal to 50 billion, right? So this vertical height, which is the vertical height here, is called shift. What's true about that versus the income change? Again, your graph may not be perfect, but which one's bigger? Change in Y? So if we drop this sucker down and we kind of go, there's your multiplier effect, right? So it went up by 50, but it went up by more than 50 because of the multiplier effect. And so the total change in Y takes into account that multiplier. So this distance ends up being the change in Y. And using our numbers that we did, it's going to go up by 250. Okay, so your textbook's got some prettier pictures of that, but that's the concept. That's how it shows out graphically, the multiplier. We've got the change in G leading to a bigger change in Y. Okay, questions there? All right, so what does the real multiplier look like? All right, so let's start over here. So we've got two different, so how about the real world multiplier rather than the simple one? What would that go in? I got a regional in here. So in the real world, we do buy stuff from China, and the government really does tax us, right? So I want to think about how this thing's going to change. Oh, gosh, did I just do that? Crap, I have a feeling that it. I think the thing was stuck. All right, chill out for a second. Let me go back to the captain.
All right, last time.
Oh, shit. All right, this marker's probably going to be done for. Okay, see if I can get a little bit of life out of it. There's a little plastic thing that sometimes gets stuck in there. I usually try to look, but okay. So we've got autonomous expenditure. We talked about. And so this is spending that does not vary with real GDP. Spending that does not change with real GDP. Other spending does depend on it. We call that induced expenditure. Induced expenditure. Our income induces us to do some spending. So induced expenditure is spending that depends on income. Spending that depends on income. Okay, so in the big picture here, the autonomous expenditure, I, G, and exports, I, G, and X are autonomous expenditures. Oh, we should add little a in here. We can't forget about little a. And little a, which we already did. Add little a on there, which is our autonomous consumption. And the claim here is that a change in autonomous spending leads to further changes in induced spending. That was that income effect that we just worked through. So key point, a change in autonomous spending leads to changes in induced spending. I'll be done writing over here. So a change in autonomous spending leads to changes in induced spending. That's the multiplier. The multiplier concept. So, question for you. if we add taxes and imports, if we add taxes and imports, will the simple multiplier get bigger or smaller? If we add taxes and imports, will the simple multiplier get bigger or smaller? Yeah. So in the example I had, the simple multiplier was 5. And so if we add taxes, would that tend to amplify things more? So this would actually get bigger, or a change of G would actually lead to a greater change, or less if we added taxes to the system? Less. Good. Why? Because why? Yeah, because the tax is going to take away from your income, right? So disposable income is going to fall. So you're not going to have as big of a spending effect if part of that is being taken away through taxes. Okay, and what about imports? What about imports? Would that tend to make the multiplier bigger or smaller? Would it amplify the effect, or would it make it smaller if we added the possibility of importing goods? Smaller. Why? Not so much that you're, well, in some respects, but I want to nail that down a little tighter. Why? If you're importing something, where's your money going? Somewhere else, outside of our system. So instead of Guns R Us having the money to go run to Applebee's with it, somewhere over in China, a company goes to presumably a Chinese restaurant, and they spend their money on it, right? So that stays outside of our system. It kind of acts as a leakage out of our system in terms of spending, because we're going to be buying the foreign good. So that's going to tend to lessen this multiplier too. All right, so good. So an increase in taxes, either an increase in taxes or the addition of taxes, however you want to look at it, if we go from 0 to something positive, or if we just increase. An increase in taxes will decrease the multiplier, because it creates less disposable income. Less disposable income, which means it's going to have less to be passed around. And then on the imports, an increase in imports, or I'm going to throw another one on you here that we're not going to use very much, but we actually have a marginal propensity to import. So we have how much of our income are we going to spend on foreign goods? So we have, similar to a marginal propensity to consume domestically, we also have a marginal propensity to import. So if we have an increase in imports or an increase in the marginal propensity to import, then our payment goes to the rest of the world, and multiplier is less. All right. Okay, does that make sense with the multiplier concept? As far as the direction if we go? All right, so here is what's really going on. The real multiplier is simply the slope of the aggregate expenditure line. In our simple model, we just had the marginal propensity to consume was the slope of the aggregate expenditure line. So more generally, the multiplier, so this autonomous spending multiplier, is equal to 1 over 1 minus the slope of the aggregate expenditure. It used to be 1 over 1 minus the MPC. Now it's just the slope of the aggregate expenditure line. So you can see where that's probably going is that on a homework or test problem, you might have to calculate the slope of the aggregate expenditure line. It's just going to give it to you, and you can use your little graphing tool in MyEcon Lab to say rise over run, up 50 over 250. What is the slope of it? All right, so let's see what this sucker looks like. Let's see, can I squeeze? I think I can squeeze this all on here. So aggregate expenditure equals C plus I plus G plus exports minus imports. I want to write it out this time. So there's our cigarettes that we related back to aggregate expenditure. And what I want to do now is just kind of put in numbers. So if it's autonomous, it's just going to be like, oh, well, this is equal to 50 and this is equal to 200. Well, 200 plus 50 is 250, right? So I'm going to change this around to think about the autonomous versus induced expenditure. All right, so here we go. So the consumption function was some number, A, autonomous consumption, plus our marginal propensity to consume times our after-tax income. This is the hardest part of the whole thing, so I'll let you guys catch up here. This is the consumption function. A plus MPC times Y is what we did before, but now I'm getting real fancy because I'm adding in taxes. So we've got the induced, we've got our after-tax income, our disposable income is our gross income. If the tax rate's 20% and I make $1,000, 20% times 1,000 would be $200 worth of tax. 1,000 minus 200 gives me $800 worth of disposable income, and I'm going to go run to the store and spend 80% of it, right? So that's the induced consumption part, or the induced spending part of consumption. All right. So that's the toughest part. It looks like everybody's caught up. Now, let me go to a different color here. The investment in government spending, those are just some number. So these little guys here, and I guess I might as well do this one too, plus exports, which is some number. So all three of these guys are just some number. Minus the marginal propensity to import times my income. All right, now this all looks pretty crazy at this point, but a number and a number and a number and a number, we're just going to add all those together. So we get our next step here is equal to some number plus the total propensity to consume times 1 minus t times y minus the marginal propensity to import times y. So I added all the numbers together. Now I'm left with this. Notice I sucked out the y here, 1 minus t. And we're almost home free. Equals some number times the marginal propensity to consume times 1 minus t minus the marginal propensity to import times income. And just an addition sign, it's some number plus number plus. Okay, I promise we won't do anything more here, but this is just the ugly way of calculating the slope of the aggregate expenditure line with all of its components. Check it out. Slope-intercept form. Here's the intercept, and here is the slope times y. For your homework problems, you pretty much just have to do this. So you're not going to have to worry about this one too much. But it's a way to kind of drive these points home of what's going to happen if there was taxes and there was imports. It's going to make that multiplier small. All right, questions or comments there? Whew, good job. All right, so you made it through that boring part of life here. So, any questions? Just craziness? You cool? Or got any questions? You just said that's crazy. It's crazy. This is crazy. This is crazy. Okay. All right. So now, what happens in the long run and short run? So I want to tie this multiplier concept back to aggregate demand, aggregate supply. So that whole mess, those two things work together to hopefully get some other. So my question is, how does aggregate demand, aggregate supply from last chapter connect back to this? All right, how does aggregate demand, aggregate supply model connect to aggregate expenditure model? All right, so we're going to draw two graphs. Make them big enough for yourself. Don't cheat yourself too much paper. We're going to stack two graphs on top of each other. Up top is the aggregate expenditure model. So do your 45-degree line. And your aggregate expenditure line. I'll let you get caught up to that point, because this is where downstairs we're going to end up doing the aggregate demand, aggregate supply. So how this is going to work is vertically we're connected. Because aggregate demand, aggregate supply is down here, that is measuring the same thing, real GDP on the horizontal axis. And then what do we measure on the vertical axis for GDP, for the goods market, aggregate demand, aggregate supply? the price level, right? So we got the price level here. Now, Keynes told us that this was a equilibrium point. And so if it is a long-run equilibrium, then this is right where the long-run aggregate supply is. So draw that line straight down. That's currently where we're at if this is a long-run equilibrium. And then we're going to have the current state of the economy with aggregate demand and a short-run aggregate supply curve. Just like what we did last chapter. So just draw a long-run equilibrium. There's going to be some price level. Let's just say it's 100. Just keep the numbers easy. So that's our current state of the economy. All right, everybody caught up? So let's do the shift. So government spending goes up by 50 or whatever it is. So draw a new aggregate expenditure line, AE2. The spending multiplier says that we're going to end up here once we get through those rounds of spending. And that'll cause output to rise to Y2. Just same graph, right? Okay. How did that happen? Well, aggregate demand was C plus I plus G plus X2, right? So it was the spending that was going on and channeling through. And so assuming that the price level stays constant, we're going to map out that aggregate demand shift. Now look at what I did. I held the price level constant, came down, created a point, and then draw a new aggregate demand curve through that. And call it AD2. All right, everybody catch that? Got that on your? All right, so, in looking at what we did up here with this multiplier effect, are we going to get that full effect down here? Is that going to be what happens? Or what does the full multiplier assume? So here's the shift. Increase by 50 using the same numbers we did before. Increase by 50 leads to a 250 increase with the multiplier. Is that indeed what's going to happen? What prediction did we make here when we did this last chapter, which we got just tested on Sunday? What's going to happen? In other words, kind of pretend I didn't do this and say, suppose the government increases spending by 50. What was your prediction as what's going to happen in the economy? There's going to be, Jacob? Increase in aggregate demand, which I've got here, and then what else? What's your prediction on GDP and price level? Price level goes up, right? In the short run, we would assume movement to point B. We go, this is last chapter, kind of ignore this for now. Now I'm back on last week. We move from point A to point B. Assuming what? What was our assumption, Ashley? All of the things held constant, specifically what, though? What's held constant along the short-run aggregate supply curve? Resource prices. Good. So along this short run aggregate supply curve, resource prices are held fixed at, like, let's say $10. So the only way that we move the way Keynes predicted with the full multiplier to get out to this point and this level of income, what's true about those wages? What's Keynes' assumption? Sticky. I heard somebody getting the sticky wages. So Keynes' short run aggregate supply curve, remember, was really flat. And check it out, if it's perfectly flat, then Keynes' multiplier has a lot of bang for its buck, so to speak. But if resource prices adjust to some degree, if there is, and in this case it's output prices we're claiming is the adjustment, then we're not going to have that full multiplier effect. So our third thing to add, we said, what will happen to the multiplier if there's a tax effect? So if there's an increase in tax, does that amplify or dampen the multiplier effect? If there's an increase in taxes, I'm just recapping what I did 15 minutes ago. It'll dampen, right? It'll shrink it. And so if there's imports, dampen or amplify? Dampen. If there's a price level effect, dampen or amplify? Dampen, right? Because here's the full multiplier. Here's the full multiplier. If there's a price level effect, if prices are indeed not sticky, then we're going to only move to point B. And so it's actually less. So again, the multiplier kind of gets chinsing away here, and we move to point B. All right, so the extra level of detail we're going to add on here is that this aggregate expenditure line was built on price level 1 of 100. This aggregate expenditure line was built on price level 1. Prices are sticky. Yes, we get this look to it. But if there's a price adjustment too, we're never going to get up to that point. The best we might be able to hope for is to get to there. And so this is AE, let's just call it 3 just for labels. And that is at PL2, the higher price level. So try to get that on your graphs. You're lining up this new spot. So the current economy never goes out to what Keynes predicted or Keynes thought here. If a price effect, we're going to move out to Y2. Oops, I guess I called that Y2. Let's call that Y3. Okay, questions? Got the mechanics down of the graph anyway? So the economics going on, in addition to the mechanics, is that we really probably never go up to here and then down to here. We probably just move up to here, with there being some sort of price effect in motion. All right, so that was the short run effect, assuming resource prices are held fixed at whatever levels they were, we move to B. Where are we heading in the long run though? In this picture, back to last week. Where are we going in the long run? Where should our eyeball gravitate towards to kind of make a prediction about how the economy is going to go in the long run? If the invisible hand, Adam Smith, lets market forces and prices adjust, where are we heading? Long run aggregate supply and aggregate demand, right? So right there is where the economy is going to head. So that's point C, where there's going to be further adjustments in the price level up to PL3. And so what is the long run multiplier equal to? What's the long run multiplier? So here's the multiplier. What's the long run multiplier equal to? we're going to end up here. What's the long run multiplier? It used to be 5, right? We calculated the 5, 1 over 1 minus the marginal propensity consumed. It was 5 times the 50 gave us the 250 change. So we claimed that the multiplier was equal to 5. What's the long run multiplier equal to? 1. 1. Close, but not quite there. So let me roll with you for a sec. If I change by 50, my income or output went up by 50 if it was 1. How much is my output going up by in the long run? 0. What's the long run multiplier? 0. There is no multiplier. In the long run, there is no multiplier. We can't spend our way into prosperity because the fundamentals of the economy lie within the long run aggregate supply curve. The potential output for the economy was based upon what? In other words, what was the shifts of the long run aggregate supply curve? Technology, good. What else? Education, yes, was one of the longer term. What else? Lower interest rates? No. That's just a price. That's the price of money. Technology, yes. Education, I can buy into. Increased labor force, increased capital, right? Physical quantity of resources. So the long run aggregate supply shifters was the quantity of resources and technology. Same thing, that was the production possibilities frontier. So is it possible for government to just go spend some money and have some long-lasting effects? Not if they didn't change the resource base, right? So did they spend the $50 billion on education? Well, now we got a potential argument that that led to a shift of the long-run aggregate supply. But if it was just a redistribution of a transfer payment, take from the rich, give to the poor, this one starts to make sense, right? If the government takes from somebody and gives to somebody else, what's the multiplier effect on that? Nothing. Assuming both go to the store and buy something. The rich person goes to Walmart and maybe they go to Target, right? And they spend their $50 billion or their $50, and then the poor person goes to Walmart, they spend $50. It's a wash. So increasing transfer payments, that one kind of starts to see one hand go into the next. We don't get any multiplier effect. Same thing if the government buys weapons and then just it's a testing thing. They just go blow them off in the ocean, right? $50 billion worth of weapons, and they just go, poof. They spent it at guns, but did we change our resource base? No. They were just kind of wasted, in a sense, right? So this is where we start to get into more details. If they bought them and now we have an inventory of missiles, how could that lead to potential increases? Did we increase our resource base? Now I'm getting kind of into the details. So we got our economic model that's an abstraction from reality. But now let's kind of bring in a little dose of reality. The model helps us see things that we might not otherwise see. But if the government takes that $50 billion and buys weapons of mass destruction, but now just has them inventoried, what could that help with in terms of long-term prosperity for the nation? Think of some things. If we have a nice military that's ready to defend us at any given point in time, how does that help people? What do you get out of that? What's that? Comfort. Sure. What else? What do you get out of having our military fully stocked? What are you able to do with that added comfort? I think we can. What other words can we come up with besides comfort? Security, right? So we feel secure, we feel comfort that we have that. What would that allow you to do better? How does that help you out? So the opposite of security would be fear. And how might you behave differently if we were operating out of fear? Yeah, so trading might not happen as much, right? How about going to work even? If you work in a high-rise building and the towers just came down, do you feel like going to work and riding up to the 47th floor? Probably a little scary at that point, right? So in terms of productivity, national security is important because it's part of our rule of law that gives us that ability to be productive so that we don't think about it. We're not scared. We can go to work and I'm not worrying half the time at work that the building's going to get bombed, right? So that brings productivity to us to have that kind of off the table. So that one gets a little dicey. What's the right amount of security that we start to be, not have that fear anymore? Well, and everybody's on a different meter, and that's part of what makes politics kind of interesting on what the appropriate level is. Okay, so the aggregate expenditure line, in the long run, holding other things equal, is right, I'm drawing this right on top, this blue line's right on top of this one. So AE4 is at PL3. I know you guys don't all have color coding the way I did, but the long run multiplier is 0. It's going to come right back down after there's price adjustments. All right, so kind of key points. The long run multiplier is 0. The long run multiplier is 0. If there is no change to resources or technology from the spending change, if there's no change to the resource base or technology from the spending, then it will all be inflationary in the long run. In other words, the long run aggregate supply curve doesn't shift. Now, Keynes looks at that analysis and he says, oh, that's no big deal. In the long run, we're all dead. So Keynes is like, we got to do something in the short term. There's enough changes going on. So that analysis isn't going to bother Keynes or Keynesian economists very much. We got to be doing something to kind of help out, at least in the short term. So the short run would kind of matter to them, in theory, to help stabilize and be a positive influence. Okay, any other questions there? Okay, I've got a special little video here that I actually just put on Rusty Con Rocks. Let's see if that. All right, so do you guys know Joe Siegel, Logan Bullinger, and Tyler Hooks? Okay? I know not everybody would maybe know them, but they did a video on Keynes versus Hayek for their video project for Money in Banking. This was just last fall, and so I added it here. So this is these guys. This is their interpretation of kind of Keynes and Hayek battle. Okay, let me make sure my volume's up good.
Latest support in Keynes here. Welcome to the John and Keynes suffering Christ. Today we're going to be some of the basic piece of the American culture. Looking forward to the great dimension and review. Look at him, we've got some incredible creatures in the natural habitat. The animal spirits out appear to lower this one's consumer confidence, and this one appears to be causing sticky wages. This is just not a good shit, but no more. I've got to see a light up. We'll throw low interest rates and government spending at them. That should line them right. Now that's how an economic ecosystem should really work. Safari Man Keynes, you've done it again. I'm Safari Man Frederick Heinrich. Don't let Safari Man Keynes run you astray. This is not how things should work. You work these poor creatures into an artificial frenzy with your low interest rates and your responsible government spending. Do you want to cause a stampede on the bank? This inflated energy is not going to last. Oh look! A bank run! And now they're more tired and more depressed than they were before. The boom that was created only led to another bust. As you listen, there's two opposing opinions in this case. Keynes believed that losing aggregate demand is key, while Heinrich believes that this artificial boost will only create a larger bust. This battle continues on even today. The question is, who will win?
All right, so that was their big project. I did give their permission to put it on the Lexicon, so we'll see. And I just put it up there, so we were the first views. All right. So, how long is the long run? How much impact can they have? Our next chapter, which is this week's material, by the way, gets into trying to answer those questions. So we're going to look at a few more theories about how this economy of ours works. And I want to start off with rational expectations. So, theories of the business cycle. Theories of the business cycle continued. We kind of started this topic before. So, the business cycle is our ups and downs over time. Expansion, peak, recession, trough. Hopefully, we're on some sort of upward trend, which is our potential, that we predict that we're going to stay around our potential. So what causes these ups and downs? Well, expectations played a pretty important role even with last week, right? We had expected income, expected price level, profit expectations. So we're going to take a little bit more of a careful look here at a theory called rational expectations. So rational expectations. So a rational expectation is just a forecast, a prediction, an expectation, a forecast based on all available information. A forecast based on all available information. So the all available information is kind of the rational part. So when an economic agent is being rational, they're looking at all the data, all the statistics, everything before they make their decision. And then the expectation is the behavior change from the forecast, right? What we think it's going to be, the forecast. All right, so if an expectation is rational, we should observe a couple things. So, one is that they should be correct on average. Correct on average. And it also should minimize error. So correct on average with minimized error. So those are a couple of the results that we'd expect to see for expectations. So, who's heard of the bell curve before? Right? The bell curve, hopefully you've seen that in your statistics classes. What does that mean, the bell curve? It's kind of one thing to say it and remember it. It's another thing. What's going on with the bell curve? Who wants to take a stab at that?
Something to do with standard deviation.
Yes, that's part of it. So the bell curve looks like this, let's say. Not quite squiggly, my hand's a little shaky there. Too much caffeine this morning. So there's your bell curve, yeah. Okay, yeah, something lies between there, and it's related to that standard deviation business, right? So what is it? What's lying between there? Well, let's add on. You guys are doing good. It's the average. Okay, so what is the average with the bell?
So it'd be like the highest point of the right side and the lowest point of the left.
Not quite.
Deviation from the center.
Deviation from the center. So what is the center? That's the average. Okay, I couldn't quite tell if that's what you're saying. So the high point here is your expected value, right? Which in this case is that we're saying the average, but it's really going to end up being our expected value. So this is the expected value. It's the most what? What's the height of this thing over here? What are we measuring on the vertical axis? Why are we expecting that? This is the part people usually don't remember. Like, what is that? Oh, bell curve, I get it. The high point's the average. Yes, good. It's the probability. So it's this observation, this number, has the highest chance of being right, right? So this number has the highest chance of being right. So over here, we're measuring the probability. All right, so now what about, you guys, I'm going to have fun with you since you guys, I like the standard deviation and the range type stuff. So what is that range? And relates to standard deviation. This is probably worth an extra credit. So standard deviation, there's something with the range, so I'm kind of building on those two concepts. Who remembers that? Really pushing you. You don't have to know this for the test, but this is total bonus material. But you guys are doing so good, I didn't want to stop your momentum. Does everybody remember that? Yeah, what was the connection? You mentioned a range. Cameron, what was your, let me just do this here. So this range, right? That's what you're talking about, Cameron, this range? So that's the range of values. And there's something tied into the standard deviation.
The number that's the standard deviation is how far away from the middle it is.
Okay, yep.
too is that like on the left curve, think about rather than on the left.
Okay, half of the observations with your output. Now you're even getting more technical than I want to go. So who remembers this range? What level of confidence did I have? 95, 90, you can have different levels of confidence. But I'm 95% confident that the value is going to be somewhere between here and here, right? I'm expecting it to be this number with the highest probability, but I could be wrong. Right? I might be here, I might be here. How many standard deviations away should I be to be 95% confident of my number? 2, bingo, Amanda. That's the buzzword I was looking for. That's worth an extra credit point. 2 standard deviations, and I think we've had enough of this game here. I don't even know how much more I want to get into it. So we can be 95% of the values will fall within 2 standard deviations of the mean or of the expected value. So that's the idea of the bell curve. So we have equal chances of being too high or too low, right? We've got equal. That's the bell part of it. Is that you might be wrong, but you've got symmetry here of being overestimating or underestimating. The bell part means it's equally likely you might be too high or too low. So we're not biased one direction or the other by choosing this as our expected value. Okay, so if we're making rational expectations, we should be correct on average or pretty close or close to that range. And if we're using all available information, being rational about it, what's true about the height of the bell and the width of the bell? The height of the bell and the width of the bell, if we're really gathering all the information possible, what should happen to it? Not looking for just a number per se.
Why?
Yeah, will it be wider, flatter, taller? It's going to be a little bit taller. So if we didn't gather all the information, we have a better chance of making an error, right? So if we gather more information, we should expect this thing to be taller and narrower, so that we're getting tighter and tighter on being right? So that's the variance and the variability, that stuff. The standard deviations will be smaller. So a rational expectation is one in which we use all information to make our forecast. And so we got this concept of the bell curve to help us think about expectations. And one of the key things is we could be wrong. All right, so how does that play out? Any questions on that? So how does the concept of an expectation play into our aggregate supply, aggregate demand? Okay, so applying rational expectations to aggregate demand, aggregate supply. All right, so draw home base for macro. Long run aggregate supply curve, short run aggregate supply curve, aggregate demand curve, all in a long run equilibrium. Let's just say we're operating at a price level of 100 for starters, and the economy's humming along at its potential level of real GDP. Okay. Now, if you guys hear that Trump is going to do some increased government spending, what do you predict would start to happen in the economy after that government spending goes on? With your last week's material, we started to get into the prediction business. Now we're starting to think about, oh, how can I apply this to my life? If I hear Trump's going to bump up government spending, what prediction would you have on the economy for the short run? Increase in Cameron? Real GDP go up? And what else? Aggregate demand would shift to the right. So we have a bump up in real GDP, and then what else are other key variable up here? Price level is going to go up. So we're expecting that policy is going to potentially have some inflationary consequences. In the short run, though, we might get a little boost in the arm, assuming that resource prices are fixed. And so, rational expectations, we're going to start to potentially form where we think the economy is going to be. We start to hear it on radio and TV, and the public forms an expectation about that policy change. So this is the expected aggregate demand. Maybe let me not do the EAD. I kind of like the EAD because it stands out better, but let's just do ADE like we've been doing with the expectation notation. That's where we think the economy is going to be, but it's not there yet. I'm just saying that's where we think it's going to be. All right, so if Trump's policies got you thinking along these lines, what might you start to do differently? Save more money, yep. So that could be one behavioral change. And then what about your pay with your boss? Ask for a pay raise. Right? Hey, this Trump guy's in office. Looks like he's going to go spending crazy. There's going to be inflation. So you might start to actually act differently now than before. And so where you think the economy is going, based on your expectation of aggregate demand, you start to form an expectation about the price level. So now we've got the expected price level, what we think is going to change in the long run. And so maybe we think that's going to come with a 5% bump in prices. So the price level you think is going to climb to 105. Now, this might start to seem a little bit far-fetched that even as a principal student, you wouldn't be able to come and graph this stuff out. But what do real people do, like your parents? What do they do? How do they get information about inflation? Where do they get their information? The news. So they listen to the news, they listen to people talk at the cooler, they go to the basketball game and they talk. Now, are they talking about inflation? Probably not, right? But are there people out there that are focused on inflation? Yeah, you go to some of the Wall Street trader, broker guys, and gals, they're all looking at that information very carefully. And they're doing their own independent research on top of all the academics maybe in the classroom universities, which they're probably slower to react than the people on Wall Street because money's at stake on Wall Street, right? So they're going to be really paying attention to it. After they do their analysis, by the way, the government's going to have some independent policy analysts doing it and different talking heads. This starts to become headlines, right? So that information starts to come out. So even your parents who don't give a damn about inflation in general, because they've been conditioned that way, that, oh, we don't really have to worry about inflation, they might start to have a little table talk. Did you see that headline the other day? They said something about inflation. What is inflation? I don't know. That means prices might be going up. Really? Prices might be going up. Maybe I better start saving or something, right? So that type of stuff starts to kind of percolate into people's behavior through news, media, and headlines. It might start with the Wall Street folks, and they're making actions right away, but it eventually trickles out to the general public as well. And so when that happens, we might start to see people adjusting based on that expectation the resource prices. So if resource prices are currently at $10, just to keep numbers easy, we'd start to see a new upward pressure on resource prices. In order to keep up with 5% inflation, they need to get a 5% pay raise. So what's their new nominal wage need to be? 50 cents up. So $10.50 would have to be their new pay. All right. So what happens then is Trump actually puts his plan into action. The government goes out and blows $50 billion on some weapons of mass destruction. So if our expectations are met, AD2 goes here. If our expectations are met, then the aggregate demand curve shifts like that. And does the economy have that increase in real GDP? Under those circumstances, do we move out to this, what we used to call point B? The current state of the economy is always shown by the intersection of what and what? Short-run aggregate supply and aggregate demand, the actual aggregate demand curve. This is the actual aggregate demand curve. This is the actual supply curve. Do we ever make it out to this point B? No. All right, so this theory has some important implications about that lag time between output prices and resource prices. What does rational expectations theory suggest about the length of time for price adjustment? Short or long? Short or long? If people are able to form expectations about what policy is going to do, as the long run, in the long run we're all dead, Keynes said, do economists who believe in rational expectations think that's the case? Not so much. So the distance between the long and the short run might be gone. And so if we're correct, rational expectations theory would predict we move from A to B. We don't ever get off of potential. All right, let me write some of that stuff out here so we got a good rabbit trail for your notes. All right, so showing rational expectations theory graph. Number one, we start off with a long-run equilibrium. Number two, public forms a rational expectation about where they think the economy is going to be. So the public forms a rational expectation about where they think the future aggregate demand will be. The public forms a rational expectation about where they think the future aggregate demand will be. And that was our AD superscript B. Taking into account all information that they have. Number three, super important point is that they're going to ask for a pay raise potentially before it actually comes. So resource prices adjust based on the expected aggregate demand. So in our graph, this was the intersection of the expected aggregate demand and the long-run aggregate supply. So my resource prices are going to start to shift. That means there's a decrease in short-run aggregate supply, shift to the left. Step number 4, we learn where the actual aggregate demand curve is. So step number 4 is we learn what the actual aggregate demand is, which was AD2, or actual. I just put, according to the graph, I just added that little ACT for actual. So step number 5, if the actual aggregate demand equals what we expected, in other words, we were correct, then the economy moves from point A to point B with no increase in output. With no increase in output and only an increase in the price level, which I didn't totally map out here. When we move to point B, then the actual new price level, PL2, is equal to what we expected it to be. Okay, questions on that? Rational expectations theory has a problem, though. Do we actually observe fluctuations in real GDP? Does the real economy experience fluctuations? Yes. So how do we get fluctuations? Don't predict it perfectly. We don't predict it perfectly. That's right. We're wrong. Are we wrong with our expectations? Sure. Within the 2 standard deviations, we're likely to be wrong. So if we underestimated the actual change, so the ADE is here, but we underestimated it, if the actual aggregate demand curve is up here, the current state of the economy is the new actual short-run aggregate supply curve and the new aggregate demand curve, and we get an expansion. So we get an expansion based on unanticipated changes to aggregate demand. If we overestimated, we estimated here, and it's like, whoops, we screwed up that one. So we overestimated the actual change, the new short-run aggregate supply curve, and the aggregate demand curve, and we get lower real GDP. So we're just wrong. It's how we get fluctuations. So on your graph, let's add 2 more lines here. One in the middle, call it AD3, and one up top. AD4. And then you can put the associated points with those. So this was AD3, so I'm going to call that Y3. And this is Y4. You can just match up whatever you guys did. And then we're going to add on, and then we'll be done for today. So number 6, this was if we were correct, but what if we're not? So step number 6, if we underestimated the change. So let's see, underestimated your AD4 range, right? So AD4 is greater than what we expected. That would be an underestimate on that graph. Then there'll be an increase in output and an increase in inflation. If we overestimated the change, that's our AD3. We overshot AD3 is less than our expected aggregate demand. We're going to have a drop in real GDP. We're going to have a recessionary gap. And inflation will be less than expected. And less than expected inflation. All right, that looks like a good stopping point. Get those notes down, and once you're done, you can head out.